Hi everyone and welcome back to my channel A in Economist. So if you are new to my channel, let me recap what we have done in our previous sessions. So we were doing what is the parameter estimation in case of time series analysis. Specifically, we have said that there are three basic methods of estimating the parameters of a time series model. The first thing that we have done in our previous class is the maximum likelihood estimation, MLE estimation, and we have gone into what will be the MLE estimation for the AR process, that is the auto-regressive process of order T. This we have already done. Now in today's lecture, I'll be continuing with this MLE process and we'll see for different time series models how it works. The second estimation process is the Yule-Walker estimation process that I'll be covering in the next video. And the third process is the least square estimation. I will be not covering this in the time series playlist as I will be covering it in details in the econometrics playlist. So this is what we have done till now. So let us start with the maximum likelihood estimator for an MA1 process, right? So we have already done what will be the MLE estimator for AR process. Now we will be moving into what it will be in case of an moving average process of the first order, first degree, MA1 process. So let's start. So the question says, suppose you have Y1 to Yn. This is the sample or the data, time series data that is available to you that is taken from MA1 process. And as you already know, if you are watching my playlist, you'll be knowing what is the general form of an MA1 process. This is the general form. I have written it here. Yt is alpha plus epsilon t plus theta epsilon t minus 1. If you haven't watched my videos on time series analysis, I'll be giving the link in the description so you can check that out. And here epsilon t is following normal distribution. So when I taught you MA1 process, I told that this is white noise. But specifically when we are doing parameter estimation, we have to define a distribution. So here I have defined normal distribution and hence this MA1 process is also called the Gaussian MA1 process. Gaussian, right? Why it is Gaussian? Because I have specifically defined a distribution that epsilon t's are following normal with parameters 0 and sigma square. So as you can see, this model has three parameters, two implicit parameters and two explicit parameters and one implicit parameter. As you can see, alpha and theta. They are explicit parameters and one implicit parameter, which is sigma square. So we can define a vector in this format theta. Theta curve is the vector of parameters alpha, theta, and sigma square. And we have to find out the MLE estimators of each of them. So MLE estimator of alpha, MLE estimator of theta, and MLE estimator of sigma square. So this is what we want to do. Now let's see how we do this. So the steps are exactly the same. Find out the conditional likelihood function first and then maximize it. So let's see how to find out the conditional likelihood function, the conditional likelihood function for this MA1 process. Now, as I have mentioned that in case of AR model, we have followed some specific steps. We have found out the exact likelihood function as well and conditional likelihood function as well. But in case of MA1 process, we'll be focusing on conditional likelihood function only. And the process is a little different from what we have done in case of AR process. So let's see. For this, what we have to do, we have to assume something. Firstly, we have to assume that epsilon naught is 0. Now, as I'll be proceeding with the proof, I'll be telling you why I have done this. So as of now, assume that epsilon naught is 0. Now write the process. Yt can be written as alpha plus epsilon t plus theta epsilon t minus 1. Right? This is what we have. Now for t equals to 1. If you put t equals to 1, what you will get is y1 is alpha plus epsilon 1 plus theta epsilon naught. So t minus 1 will be epsilon naught, right? Now, as I have told you, this thing we have assumed to be 0, right? This is 0. So what we can write here is that y1 will be alpha plus epsilon 1. This portion will be 0. And hence, epsilon 1 can be written as y1 minus alpha. Simple. This is the first step. So what we have essentially done here is that we have transformed. What we have done is that we have written in this format. We have written epsilon t in terms of as a functional form of y's. Why we have done that? Why we have done that is the reason is as follows. This is known to us. Y1, Y2 up to Yn. This is the sample. This is the data or the time series sample which is known to us. So we always try to write our entities in terms of the known figures. So here y1, y2s and y3s and up to yn, these are known to us. So I have converted epsilon in terms of y. I hope up till this much this is fine. So we'll do the similar thing for t equals to 2 as well. Let's see. For t equals to 2 from the model, this model, if you put t equals to 2 here, here and here, what you will get y2 is alpha plus epsilon 2 plus theta epsilon 1. Then what you can do, instead of epsilon 1, you can replace what we have got previously. This thing, epsilon is y1 minus alpha, so replace that. And then if you simplify, you will have alpha plus epsilon 2 plus theta y1 minus theta alpha. So in terms of epsilon 2, if you take this epsilon 2 on the, sorry, not fix it here and take the other terms on the left hand side. So it will be y2 minus alpha minus theta y1 plus theta alpha, right? Okay. So now epsilon 2 will be y2 minus alpha. And now if you take theta common from these two terms, you will have y1 minus alpha. So y2 is basically y2, epsilon 2 is y2 minus theta. And this thing again, this is epsilon 1, right? So epsilon 1. And this will be the form of epsilon. So see, we have found out what will be the first epsilon, epsilon 1, and this is how you find out what will be epsilon 2. Let me do another step for your convenience. For t equals to 3, this will be y3, the same process. I am doing the same process again and again. You can do it on your own. So alpha plus epsilon 3 plus theta, and then instead of epsilon 2, write what we found earlier. So y2 minus alpha minus theta epsilon 1. So alpha plus epsilon 3 plus theta y2 minus theta alpha minus theta squared, this. Then take this on this side, theta y2 plus theta alpha plus theta squared, that's epsilon 1. And y3 minus alpha minus, again take theta common, so y2 minus alpha minus theta epsilon 1. So epsilon 3 is y3 minus alpha minus theta into this thing is again epsilon 2. So this will be epsilon 2. So now that you have the terms of epsilon 1, epsilon 2 and epsilon 3, you can find a pattern from here. Let's compare. So epsilon 1, first term is y1 and then minus alpha. Here you have for epsilon 2, y2 minus alpha. And then there is an additional term minus theta epsilon 1. And for epsilon 3, y3 minus alpha, and then you have theta epsilon 2. So if you compare what you can write in general, what you can write, if you have these three terms, you can write the general epsilon n. What is that? That will be yn minus alpha minus theta epsilon n minus. So in this figure, you can, put the values of n, you can vary the values of n, and you will see this will be the general form of epsilon. right? So now you got this term, general term. Now what we can do, we can find out the conditional likelihood function. Conditional likelihood function, let me write, what will it be? So function of, first write whatever is known to you, y1, y2, this thing. This is known to you, given epsilon naught is 0, right? This is the assumption. This is our assumption that we have made initially. And this assumption basically helped us deriving in this epsilon terms, epsilon 1, epsilon 2, and epsilon 3, right? That is the reason of making this assumption. So what will be conditional likelihood function? So it will be function of all the known terms given epsilon not equals to 0. That can be further written as f of y1 given epsilon naught, f of y2 given y1 and epsilon naught, f of y3 given y1, y2, epsilon naught. This will go like this. Finally, we have f of yn given yn minus 1, yn minus 2 up till y1, and then you have epsilon naught, right? Now simplify further, f of, this will be epsilon 1 given epsilon naught. Why so? So if you have seen that y1 is a function of epsilon 1 purely. Let's get back this. This is y1 is alpha plus epsilon. Alpha is the parameter, so we are not interested in this. So y1 is completely a function of epsilon 1. So in the likelihood function, you can replace this y1 can be replaced by epsilon 1. Similarly, in the next, we can replace y2 by epsilon 2, and the rest portion is this. And then you have epsilon 3 given epsilon 1, epsilon 2, epsilon naught. This goes like this, and finally you have epsilon n given epsilon n minus 1 up to epsilon 0. And if you take this thing, then you will have, so given portion. So we have already derived what will be these values. So epsilon 1 is independent of epsilon naught. So epsilon 1 is y1 minus alpha. So this given epsilon naught will not be there. So there is no role of epsilon naught after deriving epsilon 1. So this into epsilon 2, this goes on epsilon n, right? Okay. Now we have epsilon 1, we know follows normal distribution with mean 0 and variance sigma square. So how can we write the PDF? PDF of epsilon 1 will be what? 1 by sigma root 2 pi e to the power minus half. And then you have what? Epsilon 1 minus 0 by sigma whole square. So this can be written as 1 by sigma root 2 pi e to the power minus epsilon 1 square upon 2 sigma square. In general, so if you find out, in the similar way, you can find out for epsilon 2, for epsilon 3, up till epsilon n. So what you will see is that, what will be the general form? This is 1 by sigma root 2 pi e to the power minus epsilon t square upon 2 sigma square for all t varies from 1 to n. I hope this is absolutely clear to you. Okay. Then the final step is to write the likelihood function. Likelihood function, this. So theta curl is the vector of parameters that I have introduced in the first slide. So that is simply epsilon, f of epsilon 1, f of epsilon 2, and f of epsilon n. So you can write these expressions individually, which we have derived here and here. So let's do that. 1 by sigma root 2 pi e to the power minus epsilon 1 square by 2 sigma square. 1 by sigma root 2 pi e to the power minus epsilon 2 square upon 2 sigma square. And this will go on up to 1 by sigma root 2 pi e to the power minus epsilon t square upon 2 sigma square. So what we can write in general is that sigma root 2 pi to the power n. To the power n, why? Here you have one term, here you have second term, here you have n terms. So you are multiplying this n terms. So this will be sigma root 2 pi to the power n. And then you have e to the power minus 1 by 2 sigma square. And then these terms are adding up. This term, this term, this term, and this term. These terms are adding up. This is minus here. So what you can write? Summation epsilon t square, and t is varying from 1 to n, right? T is varying from 1 to n. So you are adding these terms up. And the only thing you can do right now is to replace this epsilon t's. So how do you replace this epsilon t's? We have already found out the general term, what will be epsilon n. So you can do that. You can replace that. Let me do it for you. Okay. L theta. This is 1 by sigma root 2 pi whole to the power n. Then you have e to the power minus half sigma square, and then t from 1 to n. Here you have epsilon t square, so I'll be replacing that. What will that be? Yt minus alpha minus theta y, sorry, minus theta epsilon t minus 1 whole square. Let me get back and check the expression. Yn minus alpha minus theta epsilon n minus 1. So we are just replacing n by t, yt minus alpha minus theta epsilon t minus 1. So this is what you will get, and this is the final conditional likelihood function that you want. This is nothing but this, right? This is the L theta that you want. So once you get the, so let me write it down. This will be the conditional, this will be the conditional likelihood function. Conditional on epsilon naught equals to 0, right? Conditional on, why this is conditional? Because we have assumed something. This is not independent of assumption. Conditional means it is based on certain assumptions. So this is the assumption that we have made here, that epsilon naught has to be 0. So this is the conditional likelihood function, and then you have to maximize it. So maximization requires tedious, calculation. So I'm not going into that, but you know the process, how to do that. So if you know the data, if the time series data is available to you, you can easily compute this conditional likelihood function and maximize it with respect to the parameters. And that will give you your MLE estimators, mainly alpha cap MLE, then you have theta cap MLE, and then you have sigma cap square MLE, right? I hope this is absolutely clear to you. If you have any doubts, you can, comment me down below and I'll be replying to that. So this is how you find out the MLE for MA1 process. Now I want to give you a small homework. Please find the MLE for MA2 process. The process is absolutely the same. So please do this homework and let me know what you get. And now if you understood this process, the other processes that I'll be describing will be exactly the same. The concept is exactly the same. So I have written everything for you, and now I'll be taking you through the steps. So let us see how we can find out the MLE for MAQ process. So this is the generalized version of MA. And if you have followed my instructions and lectures earlier, you will know what is the general form of MAQ process. This is the form. Yt is alpha, epsilon t, theta 1, epsilon t minus 1, theta 2, epsilon t minus 2, up till theta q, epsilon t minus q, where epsilon t's are following normal distribution. So again, we are dealing with the Gaussian process, Gaussian MAQ process. This is the Gaussian MAQ process, and t is varying from 1 to n, and this time series data set is available to you. So yi's are following. So yi's are following MAQ process, Gaussian MAQ process, and this time series sample is available to you. So what are the parameters? You see what are the relevant parameters for estimation alpha. Then you have theta. So theta 1, theta 2 up to theta q. These are explicit parameters, and you have one implicit parameters also, which is sigma square, and this is all you need to find out. So the steps are exactly the same. I have written everything. So start with t equals to 1. This is the same as we have done for MA1. So write the model first, and then what you do, this 1 minus q will be minus. If you take minus from this will be q minus 1. Write everything in terms of epsilon 1. So this is the functional form epsilon 1 as a function of y1. Now, instead of epsilon, only epsilon not to be 0, you have to assume this entire thing is 0. Epsilon not is 0, epsilon, the next expression, this will be epsilon minus 1, this will be epsilon minus 2, and all the way to epsilon minus q minus 1, everything is 0. So this is the assumption. Again, we are finding out the conditional likelihoods, hence we have to make this assumption. And if you do that, this entire expression will be 0. You will be left with only epsilon 1 is y1 minus alpha. So you can do it on your own. I have given you the process. So I'm just assuming these terms are 0. The terms you get here is 0. So you will be left with y1 minus alpha only. This is the first term. In the similar way, find this out for t equals to 2. Done the similar thing. And epsilon 2 will come out to be y2 minus alpha minus theta 1 y1 minus alpha. If you want, you can take a screenshot and do it for yourself. And all the way t equals to 3. And up in the same fashion, you have to do it for t equals to n, all the way to n. And then you will get a general expression for epsilon. Please find this out, what will be the general expression. And once you have that, you can find out the conditional likelihood function. So if of firstly the known terms and then everything that you have pursued. This is the general structure of finding out the likelihood function. Firstly, write whatever is known to you, y1, y2 up till yn, and then write everything that you have assumed. So again, y1 is function of epsilon 1, y2 is a function of epsilon 2, and vice versa. Hence, you can replace this y1s by epsilon t's, and this step remains the same. And then in the product form that we have done in the MA1 also. Again, you can take a screenshot. Okay. And this is how you find out the likelihood function, the conditional likelihood function. And once you get that, you have to maximize the conditional likelihood function in terms of the parameters. And that will give you this MLEs. This MLE is thetas. Theta MLE, theta 1, theta 2 for theta 1, theta 2 all the way to theta Q MLE, and also the MLE for sigma capsule. So this is the process for MAQ. Since it is exactly the same, I have already written it previously. And the final one is the ARMA process, ARMA PQ. Again, write the model. This is the model for ARMA PQ. If you haven't seen my video on ARMA PQ previously, please do that. I will give the link in the description. This is the time series data that is available to you, and this is following an ARMA process, Gaussian ARMA process. And then what you have to do, again take t equals to 1 and find out epsilon t. So here the assumption will be a little longer. Here not only on epsilon t, but also you have to assume for yt. This is the extra part, right? This is the extra part. Since you have in ARMA, you have some portion of AR as well. So for AR, you have to make this y 0. So you can, pause your video or take a screenshot and see what I have done here. So firstly, write epsilon t in terms of everything else. And here you will have a lag value of y as well, and epsilon t as usual. So if you take t equals to 1, this is the expression, and these things we have assumed to be 0. Why we have done that? Because we know the yt is for this periods only. So y1, y2 up till yn is known. Y naught is not known to us. Y minus 1 is not known to us. Y minus q minus 1, this is also not known to us. These are unknowns. So whatever things are unknown, we have assumed it for 0. Otherwise, there is no way of moving forward, right? So whatever things are unknown to us, we have assumed it to be 0. So yt's are 0, this portion, and epsilon, these are as usual, what we have done for MAQ, this will be also 0. And once you do that, you can again find out the terms. Epsilon 1 is the same again, y1 minus alpha. This is the term for epsilon 2, all the way down to t equals to n. And find out the general expression. Once you do that, you are able to find out the conditional likelihood function. This is the known terms, and this is everything that we have assumed. Y is the term for y and the terms for epsilon, and then write it in the product form. Y's can be replaced by epsilon t, and the rest are the same. And this is okay. So this is how you find out the likelihood function, conditional likelihood function, and finally you need to maximize in order to get the MLE for individual parameters, right? So the process is exactly the same. I hope you got the process and this is absolutely clear to you. If you have any doubt in any step, you can let me know and I'll clarify that. And these are some homeworks that I have given you. You can do it for yourself. Find out the MLEs for MA2 process. I have shown you how to find out for MA1. So try your hand at MA2 process and ARMA 1 process, right? So this is your homework and thank you very much for joining in. I hope you like this video. If you do, please give me a thumbs up and do subscribe to this channel A in Economist, and this gives me immense motivation to carry on making videos for you. So thank you once more, and till the next time, I'll be in the next video, I'll be going into the Yule Walker estimation and we'll see how it works for different processes. So join me in that as well. Thank you for your time.